Hello everyone, I am Nabota Chaudhary from SYCOM C2 batch. Today I will be presenting a research paper on the modeling and management of big data management systems as a part of my IA. Big data gained awareness after the year 2010, which is when Google started storing and using user data for analysis purposes. This paper is a systematic literature review that goes through all the research that has been conducted in the field of big data management over the years and documents the developments and gaps in research. The introduction speaks about the different terms that are most commonly discussed or used in the field. The methods section describes the process used for the selection of papers relevant to the aim. The scope of this paper has been broken down to answer three main research questions to be discussed later. The results section gives a summary of the key findings in all of these papers and where exactly the said gaps and trends lie. Out of 1,457 papers, 36 were selected to best describe the focus of this research. We are faced with the question, what is big data? Big data is high volume, high velocity, and high variety data that can be further processed and interpreted. This understanding of big data becomes crucial later on as the parameters that define big data are rather heavily argued upon. The difference between the different types of data are also important as there is an evident gap in the amount of attention each of these kinds of data has received over the years. NoSQL is a database management system that imparts more flexibility than its more structured counterparts. The most commonly agreed upon data models were seen to be wide column, document-oriented, key value, and graph. In this section of the paper, the following three research questions were proposed. Number 1. How has the number of published papers about big data and data modeling changed over time? Number 2. What are the trends in database modeling and big data? Number 3. What are the gaps in data modeling and management? In order to answer these questions, the following approach was taken, as can be seen through this flowchart on the screen. As a result of the studies conducted, the stated questions were answered as follows. How has the number of published papers about big data and data modeling changed over time? It was seen that the highest quantity of papers and studies in this field was seen in the year 2018. Aside from this, the platforms where each of these papers were published was also visualized and ranked as a part of answering this question. It was seen that USA and China were the largest contributors to research in this field. On analysis, it was seen and visualized that most of the research dealt with all three levels of data abstraction. The EER, or Enriched Entity Model, was used most often in the representation of databases. The most common type of data model used was document-oriented. MongoDB was the most commonly used DBMS amongst all of these papers. What are the trends in big data research over the years? There are mainly three domains that analyzed this. Number 1, source. It was concluded that more than 50% of the relevant studies did not present their verified proposals with real-world datasets. Number 2, modeling. There are no trends as such in modeling techniques. This points to a potential gap in research. Database. For the database aspect, 55.55% of the studies focus on homogeneous database types, so the trend towards a persistent polyglot system is not observed. What are the gaps in big data modeling and management? The gaps in the research can be categorized into source, modeling, and database. Source. One of the main objectives of big data is to use the data to generate value. As a result of this systematic literature review, it was seen that most of these research papers did not use real datasets, which makes it hard to validate their usefulness in real life. Other big data main features must be guaranteed, such as volume, velocity, and veracity. This paper has previously illustrated how not all of these features are justified in these approaches. Only 2.78% of these papers have proposed a solution for all three types of data. This points to a lack of research in the individual areas. Modeling. There is no standardization regarding the definition of mapping rules for the transformation between models at the conceptual, logical, and physical abstraction levels. The 36 different studies propose different approaches for the transformation, making it difficult to choose the most appropriate one. Database. For the database aspect, the main gap found is related to the variety characteristics of big data. To manage this feature correctly, NoSQL databases must be targeted to PPS. A PPS can be obtained through storage in hybrid databases. That is, it supports different storage technologies. Only 8 studies have proposed solutions oriented to hybrid databases, and out of these, only one study demonstrated this with a real case that models and manages all kinds of data. Future scope. This research paper went in depth to explain the progress that has been made in the field of development of database management systems. A systematic literature review exploring the different fields and areas that lack sufficient research were identified. It was seen through analysis that the awareness regarding database management has drastically increased since 2018 and is expected to increase even more in the future. Areas that need more work were highlighted. Conclusion. A systematic literature review was conducted and research was organized. Trends in big data management and modeling were identified. Gaps in the research were highlighted and brought to attention. The results from the systematic literature review and from the discussion revealed some very interesting facts. For instance, more than 50% of the studies do not verify their proposals with real-world datasets. Big data's velocity characteristic is not justified by 90% of the studies. ER is the most used model at the conceptual abstraction level. Document-oriented is the most researched model at the logical abstraction level. And MongoDB DBMS is the most frequent implementation at the physical level. Thank you.